Hello and good morning, good afternoon, good evening to our viewers. Welcome to our live stream today. Very exciting. The topic is Leaving SolidWorks Behind, AE Inc.'s $1.25 million win with Onshape. And we have an incredible event planned here, okay? We're going to be talking with the founder and president and product development manager at AE Inc. And we'll be talking about an incredible story of a fast-growing custom machinery company, and how they evolved from the problems they had using SolidWorks, a system I built many years ago, to the opportunities and benefits they've achieved with Onshape. Best of all, we're going to see some live demos showing you actual machines from AE Inc. It's going to be super exciting, and we're going to open up for questions from our audience. So let me start by introducing our featured guests. We have Rob Rodriguez, who is the founder and president of AE Inc., and Jon McClary, who is product development manager there and also a longtime leader in the Onshape community, very well respected in the online Onshape community. So welcome to the live stream. We also are going to have Mike LaFleche, but let's introduce Rob and Jon first. Let me just say, Mike LaFleche is a marketing manager, well known as the Professor, and I'm Jon Hirshtick, an Onshape founder, SolidWorks founder, and currently chief evangelist here at PTC. So I'll say welcome, everyone, and I want to start with Rob and Jon. Would you introduce you? Let's start with you, Rob. Can you introduce yourself, tell us your background and your journey, and tell us about AE Inc.?
Well, first of all, thank you so much for having us be on this live webcast. It's very exciting. So let's just get right to alternative engineering. I'm an engineer, went to Michigan State, grew up from a very poor family. My family is from Mexico, and my parents were immigrants. So my dad actually worked in the fields. And I tell people I was homeless up till 5, which they find hard to believe, no running water and all that hoopla. And I started this company in my basement after leaving General Motors with a drafting board, designing mechanisms and simple machines. So I've been doing this for 30 years. And, it's funny how things have changed when we started with a drafting board. And I tell people that they find it hard to believe, dial-up phones and so forth. But, buying AutoCAD and then picking up that first seat of mechanical desktop, Pro E, oh my God, we tried everything. And this was 10, 15 years ago, but alternative engineering basically cut their teeth designing and building anything for anybody after I left General Motors. And so one of the things that separates us from a lot of our competitors is our portfolio. I mean, you can see in the background, we've got pictures of, I call it my favorite kids, because every single project is a story. But basically, people will come to us and we'll fill a gap in a factory. I tell people, what do you guys do for a living? It's hard to answer. I say material handling equipment, it's automation, it's conveyor systems, it's elevators, turntables. And who do you work for? Well, everybody. I mean, we just move things. So alternative engineering has been designing and building custom machinery for 30 years. We've been a very small company for the last 20 years. And the reason being is I'm the head engineer. I'm not a businessman. So I was driven by chasing the toughest projects. And when you're an outside firm, guys, you get the ugly jobs. You get the tough challenges. You get the high risk jobs that no one wants. And we thrived on that. And it's really made us very, very agile, very nimble. And we're the kind of company that will look at any challenge and we take all this knowledge and we blend it into different machines. So that's who alternative engineering is. And the exciting part about what's happened with the company, just a couple of years ago, I said, listen, I've got to figure out what's the long-term plan for my business. I can't keep doing this. Let's take our top products and focus on that. Let's find projects that the world needs scalable. We need to find scalable projects that we can grow. And that has happened in the last 2 years. We have seen exponential growth where we've doubled our sales 3 years in a row. It's crazy.
Congratulations.
It is.
It's amazing.
unbelievable what sits in front of us right now.
Amazing.
And
Rob,
a
I
lot
just
of
want to
kids-
say,
Yeah,
it was so inspiring to hear your story, because we hear a lot of tough times in a lot of businesses, in, you know, particularly
Yes.
in our country, in the United States, but also really all over the world. There's so much turmoil, and so wonderful to hear such a success story, and doubling year after year is amazing. Congratulations.
it's crazy. Very exciting. So
Sorry, I didn't mean to cut you off. I just wanted to tell you.
no. I mean, I hit the high spots, John.
Yeah. Okay. All right.
It's been a good journey.
Then maybe we'll go to John. John, tell us your background, and what you're doing now at AE Inc.
Well, I kind of started on the ground floor about 21 years ago. Started like sweeping floors, light assembly. Started moving my way into like saw, then CNC, laser. Kind of self-taught the code for that, and during like layoff periods where our CNC guy was away, and
That's right.
just kept moving my way up until detailing. Eventually, learned mechanical desktop. Had a good mentor to help me with that, and taught me some CAD skills, starting from scratch, basically. And then we kind of moved into SolidWorks. One guy had a seat of that, and I started detailing for him and started pushing forward with that. Then we went full SolidWorks, and then kind of came on Onshape like 14 years ago. How old is it now? 10 years ago?
10 years, yeah.
10 years. And yeah, it's I've been chasing that ever since, because the whole coming in on a browser and just no installation, the whole Google environment kind of mentality, the cloud-based, was really intriguing. And as I watched this thing grow, and we've kind of grown with it, because the faster and more powerful it got, the more we can produce, and that just made turnarounds so much quicker.
Yeah. And I also want to say, both of your personal backgrounds are so compelling, Rob, that, you grew up, I mean, what a story, growing up homeless and migrant farm setting. I can't imagine. And John, with the spectacular models that you're going to be showing us in a few minutes, and I want everyone in the audience, by the way, welcome. We have an extremely global audience, which is amazing. I see in the chat from everywhere, all over the world. So I know some of you are joining in the middle of the night. Thank you. But what I want to say is, John, it's amazing what John has done without any background as a programmer, no formal training as either a programmer or an engineering degree, all self-taught. That makes it even more amazing. So as you watch everything, it's not only what they're doing, and we can build all the software we want, but we need excellent people to make it to make great businesses and great uses of it. So it really compelling and really atypical backgrounds. A lot of people we talk to are, degreed engineers and lots of formal experience. So I just want to mention that. Can we go and say, so you tell us a little more. You've built thousands of unique machines over the last 30 years, right? What makes custom equipment design so challenging?
Ooh, I tell you, I call it building from a clean sheet of paper, John. I mean, what people don't realize is when you buy a product that's already proven, that company has had a chance to make that machine over and over again and make improvements, lessons learned. You build a machine, every machine is Rube Goldberg. It's over-engineered, because if I'm making one machine, I have to make sure it works. The cost is high. There's a lot of bugs. There's a lot of things you don't think about for service and maintenance. That's really the crust of it, because somebody will bring us a challenge, and you start with a clean sheet of paper and you design this conglomerate. And in the beginning, it was difficult to make a profit on these jobs. Therefore, okay, how do we make these change? How do we change this next generation? So here's the thing: when you build a model, I have to be able to modify it. Thus, hey, John, what can we do with SolidWorks? Can we do this? Can we do that? This guy wants it left hand. He wants it right hand. He wants it longer, shorter. And so I think with using the abilities from these different programs to modify our drawings, it's made it very simple for us to grow the business. Because what happens, you build this portfolio, John, and somebody will certainly come back. I want that same machine, but it's got to be bigger diameter. I got a different part to present. you want to start from an old drawing, but you kind of got to start over if the model was done incorrectly. We did talk about that earlier. Those are the biggest challenges.
And now, can you tell us tell us about your typical project workflow? Let's start before, back in the last era where you're using SolidWorks. Bring us into the workflow you had, and where were the friction points? Where were the challenges that you were experiencing?
John, you could probably answer that better than me.
Yeah, so the biggest thing is mostly because it's file-based. So everything that you try to collaborate with anybody, you had to be on the same page. It's like, okay, you can take this unit. So we had to actually change the way we separate our job numbers out. So, okay, he can work on that section. He can work on that section. Then we marry them all together at the end, right? And then in the midst of that, if you go out to the shop floor, which everybody has a computer out there. So if anybody has e-drawings open, that will also lock out your files. So file management was a huge friction point. So now it's so collaborative. Just we can have two people in the same part doing different edits at the same time, and it's just seamless. So
yeah. By the way, I'm asking some of these questions. I want and our audience to know it's not because I can't imagine the answers or talk about it, but I want it in your words, because I'm smiling a little bit because look, these are the problems that I saw that motivated me to build something that would solve it with Onshape. I mean, that's our story. Our team could see the problems customers had with file-based and solid software, and we wanted to try to solve those problems. And that's a big part of the Onshape story. You mentioned sharing with the shop floor, and files were okay, but there's better workflows. And so when did you realize that, lift your head up and say, hey, look, maybe take a look at something different?
I've always kind of been looking around anyway, since especially coming from mechanical desktop. If you've ever used that thing,
yeah,
it's not very parametric at all. So SolidWorks was a huge breath of fresh air for that. And like I say, now, okay, what's the next step? Well, they're all pretty much on the same level. And then Onshape kind of came around, and it's like, okay, we got rid of the biggest friction point, which was collaboration and files, right? All right, so let's try that. And that's kind of where, we kind of moved in here, and I haven't looked back. But
yeah. And when time-wise, when was this? Like how many?
Oh, this is pretty much, you guys think we're still in kind of beta. You're just so that would have been like 9 years ago, just coming out of that.
Okay. So you've been in a number of years. And Rob, when you heard about new software, were you like, oh, you guys are crazy, it's going to be too hard to switch? Or
John, I said, we're not switching. No. Because it's just like we went from this program to that program to this program. And I mean, we are all trained up in SolidWorks, and John brought Onshape on board. I'm like, oh my God, you can get one seat. That's it. I need to see proof. And I did.
You saw the proof. By the way, I think it's really great that you're sharing that with our audience, because I think a lot of people in the audience, and by the way, again, want to welcome our audience, amazing international group here from all over the world. And some of you are Onshape users, and thanks for the nice comments, but some of you are thinking about it, and you're like, hey, I've got SolidWorks. And by the way, I'm not dissing any products. I'm proud of SolidWorks, but I built it 32 years ago. So think about that. And mechanical desktop, you mentioned, John, not a bad product, but old, older than many people operate. So this is a very real issue, I'm sure, in the minds of listeners. Hey, I've heard about new software, but we have this big investment and all that. So you say you started with one seat and got proof.
I got
got proof. And can you tell me what do you remember? Like, what was the proof point or aha moment for each of you?
Right off the bat, when he opened up Onshape on his phone, I go, what?
Yeah.
What?
You saw it on the phone.
I thought it was a viewer. I said, well, that's an e-drawing. I go, no, I said, John, don't tease me like that. I remember we had to spend $5,000 a workstation, crazy money. And right off the bat, I'm like, oh my God, every time we bought a seat of a new hire, we'd have to buy a lot of horsepower.
What does it mean to have it on a phone? Like, like to have access to your CAD on your phone? Like how does that impact
service calls?
Oh my gosh. everything. Like John said, service calls, usability of anybody opening up a file anywhere with any device, whether you have an iPad, a simple laptop. I mean, basically, all of our people are all looking at models all the time as a group. I mean, purchasing, the machine builders, people doing pipe and wire, people doing service calls. I mean, we've gone paperless pretty much with Onshape.
Yeah, and it's all live, and
It's
you
all live.
know, and you're not copying files all over the place. That's a really
It's
big
crazy.
plus. So, and you mentioned cost. Let me, and of course, the big cost savings. So you like that? You don't like having to buy the workstations and all that. Let's go. And I know we're going to see demo in a minute. I want to welcome our audience and also say some of you have posted some questions here, which is great. I see one in particular coming in here. Please post questions throughout the live stream, and at the end, we're going to reserve time to answer as many as we have time for. So I know some of you are watching in different, some are on YouTube, some are on LinkedIn, some are on StreamYard, whatever system you're watching now, and we'll have a way to submit a comment, and we'll see those comments. Please post your questions for any of us about anything. Now let's go back to tell us about which features. I know we're going to see demos in a few minutes, but which aspects of Onshape have had the biggest impact in your workflow? You've already mentioned, phones. You've mentioned not having files, live viewers in the shop floor. What other features will you call out that have had a real impact on the business?
Yeah, I would say, it's the, what do you call it? The configurations are huge because it's not just a one solid table. It's like multi-layered. So now you can kind of create it just like the SMC website, and you can make lots of fine changes very easily, I want to say. But another one is FeatureScript, just being able to automate a lot of the repetitive things that you do. It's like sometimes I do the same 10 features to make a notch. Well, let's just make a feature that makes a notch. And now it's just a point, and it'll automatically pattern to any point I want. So those little shortcuts, like I say, save a lot of time. There's fewer errors in the models because of that, because it's not like you forgot a step. It's like, oh, he measured off this angle on this edge last time. Well, this time it's breaking because that edge is gone. So those kind of things if you can automate that in a FeatureScript, it helps.
And I want to mention that for our audience, you're probably thinking, well, I use SolidWorks or some other system, and it has configurations and custom features. However, Onshape's configurations and custom features take everything to the next level. We learned a lot from previous generations of CAD users. We understand what they mean. So these are concepts that have been around a long time, but we take them to another level of power. And I won't get into all the details around that. We could do that offline, or you can contact us at Onshape to explain it. But, just I want to put a note on that the concepts have been around, but we took user-defined features, configurations to new levels. And you're going to see that when they show these amazing demos coming in just a few minutes. What about working with large assemblies?
Yeah, so if you open up a large assembly with this file, you have to open each file one at a time, or the computer's doing this, and render each one at a time, all in linearly with one processor. It's not really what do you call it?
Multi-threaded, right? Yeah.
Multi-threaded, thank you.
I mean, there are certain things that are multi-threaded in the operating system, but it doesn't take advantage of all those things, right?
Yeah, so it still has to kind of go through and go one feature at a time. Onshape, it seems like, maybe I'm wrong, but once it's in the cache, it kind of just doesn't render it again until it needs to. So the more you work with the model, the faster it feels.
That's a great, I love hearing that. Yeah. And so, and I mean, we should, we are always, CAD systems are never fast enough. PDM systems never fast enough, but we're trying to use the natural advantages we have of huge amounts of computing power in the cloud and bringing that to you. Desktop CPUs are not going to get any faster.
They're kept out.
The GPU is, but the CPU, your next computer will have the same clock speed as the last computer. They're not getting faster. And multi-threading has been very elusive for old CAD, but for Onshape, we're able to put some serious, and we got a lot more plans for even better things coming. We like to say cloud native CAD and PDM is the gift that keeps on giving in the future. We have lots of ways we're going to add more. Let's go to what about measuring the impact? What's it meant for the team's speed and scalability? And how do you measure that impact? And I know there's a question about computing ROI. We'll get to that in the Q&A, but Rob, particularly John for you, but really for Rob as a business owner, you must have an idea. How can I translate that into a measurable thing, not just, hey, we like it better?
Well, one of the things that happened, John, once he kind of mastered Onshape, I know he's still learning, but the accuracy of the models, no errors, the fact that everybody could look at the model all the time and make suggestions and make tweaks, it would reduce the actual design time by tenfold. I mean, we cut our design time hundreds of hours.
Was that hundreds?
Yeah, hundreds. I mean, we could spend
hundreds of hours. Yeah.
Hundreds of hours.
Hundreds of hours. Yeah.
A typical design package might be 500-600 hours. We're now doing in a couple weeks.
So when you start talking hundreds of hours, I'm so glad you said it. I really want to underline and bold that. And that's per project.
Per project.
And this is what I want people to hear, because we believe we're capable of doing that, and we're seeing it. And by the way, we have, thousands and thousands of customers. I'm not going to say they all build the kind of models you build, because you're doing some really nice work, and we're going to see that, and we're almost there. But to hear that, I think that is something that our audience has to hear, because we see it, we hear it, you're hearing it live. These kinds of benefits are enormous, and you don't really always appreciate that on the surface. Right. Finally, last question before we go to the demos. If there's a team out there that's feeling the pain in their existing system with files and costs and lack of collaboration, and maybe there's more they want to do with configs and things, and they can't do it in SolidWorks or any other older generation system, what advice would you give them?
Oh, that's a good one. I hear this from a lot of big corporations, John, that corporate C-suite managers are not in bed with the hardcore guys down in the trenches designing, building machines. That doesn't matter who you are, but I was a user myself, and being the founder and actually using mechanical desktop and now seeing what John can do, because I don't do any of that anymore. I'm like, oh my God. I mean, that's where it all starts. So I think it's just getting your, like, a presentation, a simple presentation on the amount of hours to be saved. It's not just the hours, it's the accuracy of the models, the flexibility. We're doing some amazing things with the demonstration we're going to have, but you got to connect the two. You've got to get upper management to look at the engineering time.
I think it's just a great comment, because too often management, even in our business, it's easy for management to get drift from what's really happening.
Yeah.
And so you're saying, get down there and get close to your user. Good advice, by the way, for a lot of reasons, not just understanding CAD and PDM choices. And also, I would submit, looking for John or Michael to nod head, makes for a better culture overall. Like your team, if your team feels you care about, that you as a leader, manager out there, and some of the audience, leader or manager, I think getting close to it. That's just great advice. I didn't actually know what you were going to answer. I think that's a great advice. Get close to what the user's life. And with that, I'd like to suggest we turn to the demos, because I mean, this is the coolest part. We can talking heads, but we all love seeing cool models. I've loved it since the day I got into business, and I still love it. So we're going to see some models, huh? And I want to thank you so much for showing us actual models. It's so wonderful. All right, great.
I want to introduce this project to your audience, John.
Yeah.
This is one of the simplest machines that alternative engineering has actually ever built, but it took the longest to develop. I mean, I think John's got 5 years into developing this device. And this is nothing more than a spiral chute, or basically a one-way elevator, like a slide in a part used in the shipping industry. We did the first spiral chute for Amazon. And the challenge with spiral chutes, everyone, is the package sizes, package weights. And every single spiral chute made in America, they're all made to molds. They're made a certain width, certain depth, certain pitch. And a slide is nothing more than, a spiral chute is nothing more than a slide going around a circle, like a spring. That pitch is extremely important. You know, and I mean pitch, the slope. So we designed a spiral chute that we can change the slope and the pitch of that chute now with geometry and math that Jon has developed over the years, which is incredible. That makes our spiral chutes basically a thumbprint. Every single chute can be different now. We basically can type in the width, the height, the exit, entry, and make this spiral chute any size for any package. And we're the only company in the world that can do this. I know this for a fact because we've been studying our competition. We now can design a spiral chute in minutes instead of hundreds of hours. Like I said, that first spiral chute, oh my God, 300-400 hours.
Yeah, it was 2 weeks just to get it going.
Yeah, and now it's done fully automated, and Jon has done incredible. I'll let you take over on what we can do with this, but it's amazing.
I got a comment here from Too Tall Toby. Holy smokes,
Oh.
at a live update. Like,
Toby?
I was just going to say the same thing. It's like so fast. You have the final button turned on
Mhm.
and you're making changes. This is a custom feature that you have that is setting up your chute here. And it's just cranking away. It's on Amazon AWS doing the calculation. You're in a web browser. Right. I mean, tell us a little bit more about this, Jon. Like what's going on here?
So basically, everything's kind of made through variables. So it's just a lot of trig in the background. And this is just kind of trying to figure out what that shape is. So you see, I'm starting with simple surfaces, but I end up taking this and bring it into like a different part and using these faces to define all the sheet metal parts in the end. So like in this case, just like I say, you're just seeing these things moving really simply. The original idea was this just going to be on the quote, but it got so quick that we just show the final model now on the quote because we're already done, essentially.
Yeah, and that's, when you say final model, the model on the final model has, if I understand from an earlier call, every part detailed for manufacture, correct?
Yeah.
Manufacturable part, custom. Yes.
Yeah, every part, every fastener, every
one.
You know, I often say like CAD sometimes is a story of really old visions and just new realities. I've been building CAD and PDM for over 40 years. And, you know, like this is what I imagined parametric CAD would do, you know, 30, 40 years ago, but it didn't. You know, it did it for smaller things, or it would be slow, or it would be brittle, or whatever. And we just kind of make that dream into a reality. And I want to emphasize that, yeah, we're super happy. And when Too Tall Toby, by the way, welcome. We have a celebrity in the room here with Too Tall Toby. You know, when a guy like Toby says, you know, holy smokes, is that live update? Yeah, it's live. There we go. Thanks, Toby. You know, it's totally live updating, and the speed is amazing. Now, I want to say, sure, we've done a lot of work at Onshape, but it's also about Jon and what he's done. He builds very good models. This is a very, very good user, you know, operator here. And, you know, we can build, like I said, I said this earlier, I'll just keep saying it. It's not just about what we build. It's about getting the right people operating it. And hats off to you for embracing a new workflow and for trying something more ambitious instead of just doing what you'd done before. And this is a result of you doing great work, but we're super proud. And the speed is remarkable. And the fact that it holds together, you're not making scripted changes here, right?
No.
You're kind of you're not saying, oh, I know that this exact change will work because I've prepared it. Like you're making, you know, fairly, you know, just riffing here a little, vibe catting.
Yep. Yep. Just playing with it, see if it, you know, fits within an angle that works for the package. And
this is actually quite interesting what you're doing here, Jon, because, you know, what you see here on the screen on both sides, you have your part studio on the left and you have an assembly on the right. the assembly has configuration data, right? You know, so like your part studio is where you've constructed, I can't quite read the number, how many parts you have there, 30 something parts, physical parts in the part studio. And then you've dropped that into the assembly. The assembly is live updating, of course, because your part studio is
2,300 parts in the right?
yeah,
Yeah.
2,300 part assembly, fully detailed with all the hardware. And it's configured, and it's got multiple configuration options. You have a list of configurations, but you also have a choice of whether you want to swoop or not, right? So it's like, that would require a very large table in Excel to do this with, like design table style configurations in another CAD system, right? So, this like to set this thing up, John, like, you know, to configure this, like what was involved in that? Like how difficult was that, do you think?
So basically, like I said, the background is nothing more than a bunch of variables. So, you know, a sheet metal table, it's kind of built in, right? And then all it's doing is just pushing out some math.
Right.
And
so what we're
the end
looking at
result
here
is just setting variable.
For people new to this is FeatureScript. So this is the code that drives your custom feature that define the parameters to drive that entire chute system. So you created a custom feature with your manufacturing information, like the types of sheet metal gauge that you use is here. It's not other people's gauges. You know, these are obviously standards, but it's like, you know, these are the gauges you use, and it's not no more, no less, right? It's you've defined it. This is your engineering knowledge right here, and every time you do a design, it's going to utilize that knowledge.
Yeah, I want to add that when we designed Onshape, we had identified that almost all users wanted the feature set in a parametric CAD system to be different. You know, they want their own features. They want it, but prior to Onshape, those user-defined features are always kind of kludgy. They're not first-class citizens. With FeatureScript, John's feature for doing the chute that he built, and that's one feature on the left, right? You know, that you're showing. It's a super complex one. That works as fast and reliably as if we wrote it into the CAD system, because we write our features in FeatureScript also. Our built-in extrude, fillet, shell, loft, sweep, you know, draft, all that stuff is written in FeatureScript, and we let you use the code open source. And so, I don't know, John, if you looked at our code, my point is the user-defined features are equal citizens with the sort of built-in features. And that's the magic of FeatureScript, I think. And so that's what you're seeing. And again, John's very good at using these tools, very good. But, you know, anyone can do this potentially. And we have a lot of online learning tools, right? And more coming. So I'm just telling you philosophically, this was, and the combination, we see a lot of times the combination of custom features and our better configurations makes for a really powerful combination.
And you have a configurable BOM here as well because of that, right, John? Like, you know, the bill of materials here is updating live based on your selections. You have cross-highlighting, different ways of representing it. Maybe you can tell us a little bit more about, you know, how you handle, you know, your parts, you know, getting them out to manufacturing, you know, how you've, you know, put this together with modeled items and non-modeled items alike. It's really impressive.
Yeah. So while we were talking, if some people may have noticed, I just put a detail and name for the entire project. So even those things are very fast because you can just use the power of a Google Sheet to get all your properties, paste them in, and now that's done. So now we can actually print these off as a PDF, and they're ready for manufacture.
Yeah, so, yeah, simultaneous bill of materials. That information is now everywhere. You know, it's in a part. You know, you added it to the BOM here just by copying and pasting it into the BOM and Onshape, and of course that updated all the properties and all the parts that were related to that. So if you had a drawing or a release package, you know, that information is there now.
Yep. And one of the implications, other than saving a lot of time, we talked about some of this in a call we had earlier, but what are some of the benefits to you and your customers, the people who are ultimately getting the oh, there's the drawings. Wow.
Oh wow.
So now it's just a refresh, and then all these properties will fill in. So that's basically all we have to have.
I mean,
So
guys, we're not detailing anymore.
Oh, you're not.
All the manufacturing drawings are done automatically. That just blew me away.
yeah, I just got to clean these up, right? Because a bigger part's might have to scale down, but that's the extent of it.
Yeah.
The
That's
the,
beautiful sheet metal drawing. You got your flat pattern. I mean, this is like, not a, everyday stuff. And it's a beautiful, beautiful looking drawing.
John, this has actually spoiled our customers. They think that every time they see a spiral chute, it's sitting on the shelf and that we can ship it in, 2 weeks. It's still a custom design chute that we sometimes charge for that, sometimes we don't. But basically, you're getting a custom chute instantly, and we can deliver a chute in 4 or 5 weeks that used to be 18, 20 weeks.
Mm-hmm.
I mean,
And
it's
and the customer is getting exactly what they want. Right.
Exactly what they want.
Which you were telling me, Rob, no one else, prior to you, no one else would really do that. The customer had to compromise and say, well, I assume that means I can't lay out the warehouse the way they want or the manufacturing line, or they have to compromise efficiency or speed or something too.
You're typically buying a product out of a catalog from the other manufacturers.
Oh, there's all the customization.
Right.
So it's like getting tailor-made and so
imagine having your car longer or wider. Nobody would do that.
Nobody would do
We basically are doing that with our chutes right now.
Yeah.
Okay.
And this is, it really is so cool because it is this is what, CAD should be, It's like if someone were new to CAD, someone comes out of engineering school and, comes in, didn't know, they'd say, oh yeah, this is what CAD's supposed to do, right? That's how I feel anyway. And that makes me, happy. And I see some questions coming in. We'll get to these questions. Actually, since these questions, there's a couple questions that relate to this model. So maybe we'll take these while they're open here. I see that different settings may produce a different number of parts. Can drawings be dynamically created as necessary?
Dynamically created? I don't maybe like the API or something, right?
Yeah, maybe with the API, you can definitely do it with the API. But like what you showed, like you just made a configuration change, you update the drawing, you have a new drawing, it's been automated, right? So that's one way of handling it, for sure.
Yeah. So I pretty much have them all pre-drawn because I know how many parts, and then I just we literally just delete the parts out of the drawing book that we're not using.
Okay.
Makes sense.
This one now has been updated, so you're going to see all the errors I'm going to get. But this is just a simple replace in a couple of dimensions. Where's my page down?
And by the way, I can't resist a comment that, we, as many, we're doing a lot of AI projects now here at Onshape. And, we released our AI advisor with several upgrades already, and biggest one recently. And by the way, I know I checked our usage numbers yesterday and it's growing, it's skyrocketing rate of usage growth. So thank you out there for using it. I hope it's valuable, but I'd like to think someday AI could help with some of these automation tasks like cleaning up a drawing. I don't think it's going to design the chute, but it could help with this kind of task, hopefully.
Yeah.
We have we're actually doing some, I'll say, investigations into drawings with AI. It'd be easy to ship something now, but it wouldn't be as useful on professional cases. And that's what we're seeing. We want to make sure it's useful. Let me go, can I go to another question here? Impressive model question. Could I assume he means you're a customer, configure this model themselves through some sort of interface?
That's the next step.
Yeah.
We would like our customers to go to our website, enter in the spiral chute data, and they would actually get a model generated in front of them with a price. And then we're also going to tell them, yes, it'll work, no, it won't work. John's put limitations so that if you make a spiral chute too shallow, it's going to say, warning, you don't want that spiral chute to be too shallow, otherwise products get stuck. that's the end goal.
Mhm.
Yeah.
It's-
That is a really impressive vision, and how cool that would be. And
Mhm.
that's going to take some work. We went directly enable a very different looking website. However, I know what the professor's thinking. You could, and John probably knows, you can make a publication to simplify the UI quite a bit. So you wouldn't see all these tabs. You might only expose,
Mm.
a smaller.
Yeah.
You can.
Yes.
Onshape has this capital P publication idea, which is basically a way of reducing the data visible so that you can have that live access to data, but through only seeing the portions of data you want and through a simplified UI. And that's something that customers use for, shop floor and other consumers. It might be applicable here. It might not. Hard to say.
Yeah,
but
I think it is. I think that you have a lot of choices, when it comes to this with Onshape. You can use publication, you can use the API and connect, that way. You can use partner apps that do this as well, that are in our app store, that will take configurations and turn them into web pages with GUIs, that are up to you. So
Oh, great. We're going to another example. I love it.
it's a huge assembly.
Yeah.
Oh my
Yeah.
God.
Okay. Tell us about this. And again, this is all real time. By the way, I want to
All
show
real
the
time.
audience here. No tricks here. This is live demoing on standard internet, standard computer. There's no installed software. There's no files, right?
Over a live stream.
I feel like a magician. There's no funny business here. And we don't even think about the idea that John's using this on the same network connection computer that he's doing video live streaming, sitting next to Rob on the same connection. We're all doing video, audio, live streaming, and the connection. We don't even think about that. But go on, tell us. I'll shut up. Tell us about this model.
So this is one of our more standard products too, outside of spiral chutes. It's basically heavy loads are kind of what we work with, somewhere between 2,000 5,000 pounds. So it's a CDLR conveyor. So it's going to be rollers driven by chains in between each roller, and then a motor to drive those. This was our first attempt into throwing this into Onshape. So this is a pretty recent model. And this one just shipped last week, I believe. We're now making more improvements to it to try to speed up other aspects, but this one kind of flew through without even having to defeature any faces. We're still got all the text and font. We didn't bother even to get rid of it, because why bother if it's got the performance? So even our tags have words on them, so that the assembler knows which tags to put where. We get decals showing where the center of gravity needs to go, where our lift points are supposed to be, so that there's no confusion later on.
If I could chime in, what's kind of cool, John, I mean, all of this engineering makes our custom products look like they're not custom. I mean, no one can do this with custom machining. We've got tags, our sensors, our cables, our wires, our tags. Everything to make that machine complete is now modeled in everything we do. But this is a custom order. But this is something that can get modeled very quickly now. And the next challenge for John is to automate our powered roller chain transfer conveyors, which is what we're selling a ton of right now to all different industries. That conveyor system could come from a number of different companies in this country. Because the loads are so heavy, a lot of people won't take that order on. So to move a 5,000 pound container through rows and chains is a it's a custom conveyor system, not for AEI though.
And when you're building custom, it's a great line, Rob, that you want the custom product to feel like it was mass made, have that kind of quality, which is, by the way, a theme I'm seeing in other customers in diverse industries. Like I visited a customer who makes customized add-ons to cars, generally fancier cars for his clients. And, years ago, he installed stereos. Now he'll do custom engineering, fabricating things that look like they were made by, by Cadillac or Ferrari or someone, to add into the dashboard of a car. And he was talking about, he said, I want it to look like, like Ferrari or Lamborghini made it, not like, I made it in my shop. And so that's one thing. The other thing I'm thinking is you're taking big risks here with these projects, right? Because if you engineer it and you build it and it doesn't work, you know, you really have to be very confident, right? Because you're not making 10 prototypes that then you're going to monetize out through making 10,000 down the line. You've got to get it right and feel
You've got to get it right. Every
Risk.
order just is the prototype, actually. That's what separates us from a lot of companies. We build one-offs all the time, but now we're building dozens and dozens of one-offs. That's the growth.
Yeah, it's really, and I love seeing again the speed, and again I love seeing Onshape this running this quickly on real models. But again, I give a lot of credit to Jon. Those of you who are out there, if you're looking at Onshape, new to Onshape, remember that best practices around large assemblies are really important to know and follow. We have a lot of content online, but with the AI Advisor is an excellent tool for that. You can ask AI Advisor, hey, here's what I'm trying to build. Give me some advice on structuring my assemblies and data management to get this kind of performance you're seeing.
Yeah, this performance is special, and it's because you've done things the right way, Jon. Like you had those variable studios on your on your screen earlier, right? This information is units aware calculation management for your entire project that you can reference in more than one tab in your document or other documents, right? You essentially have units aware calculations that can be attached to anything, and then you can use these calculations to calculate other things as well. I saw you had two tables, like one table for your main parameters, another table for something called CDLR or something like that. Why do you do that?
These are the global parameters. So the other table you saw were the local ones, because I'm still also using variables to kind of pull out the calculation so you can actually see it kind of in your face, right? You can see what the results are over here.
Right, yeah.
It also kind of shows you over here what the results are.
Right, so this is actually, like, Jon, like you probably like computer aided design. Like this is like the computer actually helping you in the design process, right? It's like you're showing your calculations. It's not just hidden away in your engineering notebook somewhere for nobody to access, right? Everybody can see how you arrived at this information, at these decisions, right? To make things size.
Yeah.
And can you tell us about data management? How are you controlling this data? So you've got the right assembly on screen. Everyone agrees. Maybe Rob gives the thumbs up, and you're ready. What are you doing from data? How do you version release the data?
So we typically will try to stay to one version, one branch, and then we just kind of release through PDFs and stuff. So we don't go too deep into letting our shop pull their own models. We kind of spoon feed. But that is there. I'd like to get there, but I don't know. It's like I have a trust issue with people with all the versions there. How do I get them to pull the correct one at the correct time?
Well, Jon, we need to get you looking at publications. That's just what with publications you could say, hey, and again, just a quick tip to our audience, you can say, hey, I want to create a publication that only shows this released version of this set of parts or this subassembly. And you send that link to someone, that's all they see. They won't see all the other versions and things. However, I want to emphasize there may be reasons why that won't be what you want here. I'm just saying that's a tool, and a lot of people don't know about it. Just oh, wow. Oh, okay. This I like seeing too.
So we do use publications, especially for communicating with customers.
You do use it, yeah.
Yeah, so then they can just download about it.
Yeah,
right.
So all about publications, and so this, they're just another tool. We make tools. It's ultimately, I keep saying this over and over. It's the decision. The user has to figure out how to use the tools.
I think this is so important because, you're going from like a Windows file-based approach. When you're going in the Onshape, and Onshape has built its own database-driven system for managing everything to prevent a lot of issues. But it's like a fish coming out of water and trying to breathe. It's like you're when you're going to this for the first time, you're used to like going to your map to network drive on the network to go get your PDFs and things. You actually found a way to work in that hybrid world, right?
Yeah.
Which I thought was interesting, like, you know, making it easy for your shop floor to access information the way they were used to, right? So like everything in Onshape's a hyperlink, right?
Yeah.
You have, I mean, I won't steal your thunder.
Oh yeah, this is cool.
Let's find a job that we released recently, I guess.
But just
Yeah,
to
we
show
use
you, like,
hyperlinks.
you don't have to like throw everything away that you're used to when you go to Onshape, right? That's the thing I'm trying to like. I
Yeah.
thought it was really, really cool how you did this.
Yeah, so we released, so we'll have our drawings are going to link to the Onshape drawing document.
That's so cool. So
The
those are
models will be linked there.
so to be clear, you're in Windows File Explorer, right?
Yes.
Right.
Yes.
And you're adding URL links, web links to Onshape docs that appear to a user who's used to looking in files and folders.
Right.
They can find that in the folder, and it kind of makes it easy to find while still offering the direct access to the live web data. It's a very clever technique, very clever technique. And hey, a couple of questions that I think are good to talk about while this model's on the screen. Are total costs automated is a question here. I think they're referring to this model here.
Well, so the cost of each part. Actually, Rob's been trying to get me to get that set up too.
We're so close. Well, you know what's the next challenge is once we build a model that we can evaluate every single part, John, and assign a price to it. Like, I know we can do it. I mean, SolidWorks has a version. You guys have a light version. Like, I want to be able to count features, tap tools, machine surfaces, and then assign a price because we know how big each piece is. We know how long the cuts, the laser cuts, how many bends we have. John did create a program that I have to put the data in that will give us the price of that product. So that's the next challenge. We do have a couple products that are generating hours, man hours, laser cut, bend time, so that we can put a price tag on it instantly.
And I'm going to also turn to a couple other questions we had earlier here because we now are coming into the home stretch. It flies by. So I had a question earlier here about, okay, we said in the promotion for the live stream, we talked about a $1 million plus ROI. And we have a question. Can you all speak specifically to how you calculated this 1 million plus ROI?
That was a really challenging. That was brought to me so long ago. I mean, what we looked at is the amount of manpower hours that would be used to create different design packages, the amount of hours to print the files, take a job, deliver it to the shop on paper. I mean, this is where you got to get the upper management to look at the process of delivering a package through all the manufacturing departments. I mean, we streamlined all of that, guys. I mean, the tool room, the steel ordering, it's all now paperless. It all goes straight from model right to all the departments. We just cut out a lot of red tape in AI.
So calculating saved hours labor was a big part of that $1 million.
I mean, John's given us a bomb for material. You know, I mean, if you can see this spiral chute, it created the number of sheets we need for purchasing to buy the steel. This is for one. If somebody comes in and orders 20 spiral chutes, we can basically tell our purchasing department exactly what they need to buy the minute the quote was sent, which is amazing. I mean, as soon as we hit send, I have all that data at my fingertips. I mean, John's used Onshape to its fullest capacity.
Oh, I love that sheet layout. That nesting. That is really cool, John. And again, hats off to you as a, obviously brilliant user. I want to get to a couple more questions here. We're going to try and cover as many as we can. Question here on fonts. This may be something that that the professor can help me answer. Any hints on how we make fonts work so robustly and quickly? I assume Onshape has curated fonts internally for CAD use specifically. Professor,
Yeah.
I think I know the answer, but you may know better than me.
Well, yeah, I think, it's less about the fonts, but more about how we're serving up the graphics and what we do with the graphics once they're loaded up on the screen, right? Because if you were zoomed way out, you wouldn't see the detail of that graphic, and Onshape would do things with the browser to make it not render it with the highest tessellation possible, right? So there are things that we're doing smart. We're taking advantage of the most powerful and most widely used application in the world, which is a browser, like the Chrome browser, right? That's probably the most widely used platform on earth for computing, if you think about it. We are piggybacking on technology that is in that, right? There's graphics technology, and we add on our own, of course, special sauce to control that graphic.
So the answer is yes. We do have curated fonts for CAD use, but that's not the reason. That's not the total reason that it's so quick.
Right.
And we're trying to avoid work for the user to do things like, going into a different mode to get a faster assembly or something. We're trying really hard to avoid that. And now we're working with customers on some really incredibly pushing the limit in assemblies, and things like aircraft industries and things. So we're really pushing it, but we have a lot of new tricks, and our team, those of you who've been with Onshape a long time know that our team keeps making things faster. And I want to have a big thanks to our graphics team and our assembly team and R&D. If any of them listen to this, I just, we thank you, because this is why they do what they do. When we see this, can I ask, in these machines you're showing, it looks like you got a new, these larger assemblies. Can you give our audience a sense of part count on the conveyor or on this machine?
There's about 630 unique parts. So there's about 6,000 parts in this assembly alone.
1,000 instances, yeah. And what about and you don't need to put, oh, by the way, you can go back to the conveyor. That's another cool thing. He's got a bunch of these open at the same time,
yeah,
right?
that's right. He's got many tabs open.
Yeah, and there's no smoke coming out of your computer, right, John?
No.
No fan noise. I'm just curious, on the conveyor, that one looked like a high part count. The big conveyor there.
Yeah, this one.
Scan some more of these questions here. Yeah, on the conveyor system you showed.
Oh, this one?
Yeah, that one. I was just wondering if you had
324 unique parts.
Total part count.
That's what it's about with machinery, though. It's like you have lots of,
Lots of pieces.
Actually design,
but how many instances? That looks like a pretty high instant count.
Yeah, 6,000 or so.
Yeah.
A little over 6,000.
Yeah.
And it's complex geometry too, with those frames and great looking geometry.
Here's a great question. Coming from SolidWorks, do you miss features? If so, which ones do you miss the most?
So that list has been getting shorter. I'm trying to actually think of anything right now that I have missed recently. It used to be patterns. Well, Replicate just blew that out of the water. Used to be drawing tools. Those are starting to get better and better. Now we can do more actual sketching in a drawing and changing their line colors. So that was huge. That's come back. All right. So one feature I can say, alternate position views in drawings, showing movement, like having a view of it extended and retracted on the same view.
That's true.
Yeah. So that's something we did lose that capability. I would like to see that come eventually.
I'll have a workaround. I'll have to follow up with you, but we should.
I have a workaround too, but it's basically layering right over the top.
I got to say, we are out of time. I only want to say one big thing. A big thank you to Rob and John for taking your time and for opening the doors to get an inside look at what you're doing, which is so rare to get. And I also want to say that anyone out there who's looking at custom machinery, you got to talk to AE Inc. Okay. And just give everyone your URL for your website so they can get in touch with you after this.
Perfect. Thank you.
AEinc.com.
AEINC.com.
Never mind.
And,
That's it.
you guys were fantastic, and I can see it's no secret why you're obviously growing rapidly and doing great work for your customers. Proud that we're part of this story. Thank you so much, and to our audience, thanks for tuning in. Hope it was valuable and interesting. I learned a lot. Hope you did. See you next time.
All right. Thanks.
Thank you.
Thank you. This is fun.